Mathematically, this is a very simple problem. However, I want to go through it because I want to make sure you understand how to think in terms of Newton's second law. So we have a man standing on the floor. Now we know that gravity is pulling down on the man. So there's a force due to gravity that's pointed down. However, we also know that the man's standing still. So there must be a force counteracting that gravitational force. He's not accelerating downwards, so there must be a force counteracting the gravitational force. We already learned what that force is. It's called the normal force. The floor pushes back on the man with a force that's equal in size but opposite in direction as compared to gravity. So we can draw another arrow and we can label it F normal. That's the normal force. We know it's opposite gravity because it's fighting gravity. The man's not accelerating downwards. And we know it has the same magnitude, so that the total sum of all the forces on this man is 0. And the question is, for a 75 kilogram man, what is the value of F normal? Well, think about it. As I've already told you, the normal force has to be equal in magnitude and opposite in direction to the gravitational force. So, if we knew the gravitational force, we'd know F normal. But we know the gravitational force. The gravitational force is simply the man's weight, right? Well, unfortunately, we're not given the man's weight. We're given his mass. How do we know that? Because the unit is kilogram. So we have to convert from kilograms into newtons so that we have the weight and therefore the force due to gravity. So the weight is mass times g. We don't know the weight, but we know mass, 75 kilograms, and we know the acceleration due to gravity, 9.8 meters per second squared. So when we work that out, we find that the weight is 7.4 times 10 to the 2 kilogram meter per second squared. Well, a kilogram meter per second squared is the same as a newton, so the weight is 7.4 times 10 to the 2 newtons. Well, the weight is the force due to gravity, so F gravity is 7.4 times 10 to the 2 newtons. Since the man's not accelerating downwards, the normal force has to be equal to that in magnitude but opposite in direction. So the normal force is 7.4 times 10 to the 2 newtons straight up. Now, this may seem like a simple problem, but the reasoning that we're using is fundamental in analyzing problems involving Newton's second law, so you have to get used to it. We notice that the man is not accelerating. That tells us the sum of the forces equals 0. We can figure out one force, and if we know one force and we know the sum of the two forces has to equal 0, then by default we know the other force.